Hello friends, before going to exercise 3.2, let us see what is the concept used for doing all these problems. Here we'll go into all the trigonometric values which are used in different quadrants. How do we get those values in those quadrants? That is 0 degrees, 90 degrees, 180, 270, 360. When it is in this quadrant, first, second, third and fourth quadrant, what are the different values of the trigonometric ratios? We'll just see. So going into the concept, trigonometry values at different quadrants. So now you're having this x-axis, this is positive, this is negative, this is y positive and y negative. So now here this is 0 degrees, this is 90 degrees, this is 180 degrees and this is 270 degrees, and then you're having again 360, so on. So in this is called as quadrant 1. This is quadrant 1. This is quadrant 2. This is the third quadrant or quadrant 3. And this is quadrant 4. So now these are the 4 quadrants which you are having. So now here, in which quadrant what all will be positive, which all values will be, trigonometric ratios will be positive, which will be negative, we'll just see. So over here we having one value. There's a logic which we can use here. So we can write that logic in this way. We'll write in a so it is nothing but all silver tea cups. So now you can see that in the first quadrant you have all, in the second quadrant we have silver, the third quadrant we have tea, in the fourth quadrant we have cups. So over here all silver teacups, if you remember in this order, that is the anti-clockwise direction we are writing this. So when it is meaning as all, what happens to all the trigonometric functions, we'll see. In this we have that all the trigonometric functions, that is sine theta, cos theta, tan theta, cosecant theta, then we have secant theta and cot theta. All these are positive in this. So for what are they positive? That is for 90 minus theta and for 360 plus theta. See, from here you are having this as 360 and this is 90 minus theta and this is 360 plus theta. So here now in second quadrant what do we have? We'll just see. In the second quadrant here you are having sine theta and 1 by sine theta, that is cosecant theta. These two are positive in this quadrant, and the remaining all, that is all the remaining whatever other than sine theta and cosecant theta, all are negative. So then we have here in t, in this third quadrant it is t means, what does this mean? It means tan theta. And what is the inverse of tan theta? 1 by tan theta is nothing but cot theta. So these two are positive. The remaining all will be negative in this. Next, in the fourth quadrant what do we have is cups. Cups mean it is cos theta and what is left over? Secant theta. 1 by cos theta is nothing but secant theta. So these two are positive. So what is the value we can take in these in this range? We'll see. Here you are having it is either 90 minus theta, 90 degrees minus theta, or 360 plus theta. You can see over here these two can happen in this first quadrant. In the second quadrant what can happen? 90 plus theta and 180 minus theta. These two can happen, isn't it? Because you can see in that here what is all those which are less than 180 and lying between 90. Then you are having in the third quadrant what will be there? 180 plus theta and 270 minus theta. And in the fourth quadrant, what do we have? We have 270 plus theta and 360 minus theta. So wherever you're having this in the place of theta, if you take it as cos 270 plus theta, it will be positive in this fourth quadrant. If you're taking cos 360 minus theta, you'll get in the fourth quadrant it will be positive. So then if you take cos 360 minus theta also, it will be positive. Secant 360 minus theta in the fourth quadrant will be positive. So now here you can see if these values are taken here in the fourth quadrant, because they lie in the fourth quadrant, you can see that cos theta and secant theta are taken as positive over here. So now here we can just see which will change and which will not change over here. So here in this, what is the change which is going to take place, we'll just see here. So here you are having in this, so for theta value, at 90 degrees and 270 degrees, what will happen here is, in this all the trigonometric function changes. That means here sin theta becomes cos theta and cos theta will become sin theta. Then secant theta will become cosecant theta and cosecant theta will become secant theta. Then last you're having tan theta will become cot theta and cot theta will become tan theta. So this is the change which can be taking place in this. So for theta value at 90 degrees to or 270 degrees, that means when it is taking place as when it is having a change of 90 minus theta and 270 minus theta, or 90 plus theta or 270 minus theta, so you'll have this change which is taking place over here. Or you can write this in this way, that is 90 plus or minus theta, or 270 plus or minus theta, you will have this change which take place. That means all the trigonometric functions will change. Trigonometric functions will change. So here you have to remove 90 and 270, that is whether it is plus or minus, it will happen in this way. That is sin will become cos, tan will become cot, secant will become cosecant, and also you can see cos will become sin, cosecant will become secant, cot will become tan. And for the next one where there is no changes, that is for theta value at 180 plus or minus theta and 360 plus or minus theta, here you can see that there is no change in the function, no change in the trigonometric function. That means here you will have that sin theta will be sin theta itself, cos theta will be cos theta, cosecant theta will be cosecant theta, secant will be secant, tan will be tan, cot will be tan. Cot will be cot itself. So these are the changes which we can see over here. So if we go into different problems over here, you can see, we'll just take some examples. In this example problem, what will we have is, suppose we are having sine of 90 minus theta. Now 90 minus theta will change here, because plus or minus there is a, for theta value at 90 and 270, that is 90 plus theta or minus theta, sin theta will become cos theta. So now here it will become a cos theta, but we have to see whether it is positive or negative. Now you know from this diagram over here, in 90 minus theta it lies in the first quadrant, all are positive, so therefore it will be a positive value. Now next, if suppose we are taking cos of 90 minus theta will become sin theta, and this also will be positive because it lies in the first quadrant. Then suppose if we take sine of 270 minus theta. 270 minus theta also here you can see, because 270 minus theta also there is a change in the trigonometric functions. So therefore sine will become cos theta over here. And this 270 minus theta we have to see whether sine is positive or negative over here. So in 270 minus theta you have only tan and cot positive, the remaining all are negative. So therefore this will become a negative value. You will get here minus cos theta. Okay, next in the same way, if you take sine of 180 minus theta, 180 minus theta, this will not change, so you will get back as sine theta, but you have to see whether it is which quadrant it lies. So 180 minus theta lies in the second quadrant, and you are having sine and cosecant as positive, therefore this will be positive. So in this way we can do all the examples. So in making this, remembering all these, we'll just go into the what is this next exercise, that is exercise 3.2 of trigonometric functions. So hello friends, with the introduction given, we'll just start off with what is exercise 3.2. What is the first problem we'll see. In exercise 3.2, the first problem is find the values of other 5 trigonometric functions in exercises 1 to 5, where the first one is cos x is equal to minus 1 by 2 and x lies in the third quadrant. Now for the solution, what is the third quadrant which we are having? It is given, what is given to us? It is given to us that, given that cos x is equal to minus 1 by 2. Okay, so therefore other trigonometric functions means we have to find out what is sine theta, what is tan theta, what is cosecant, secant and cot. So now here cos theta, you have inverse of this secant theta is equal to 1 by cos theta. So therefore, or cos x, which is equal to, this is, if you substitute the values, 1 by minus 1 by 2 means it becomes 1 by 1 by minus 1 by 2 means it's becoming minus 2. So this is secant theta value. Now you also know that we can consider this one, consider sine square x plus cos square x is equal to 1. This is the identity which we are having. So therefore here you are having sine square x plus minus 1 by 2 whole square is equal to 1, since cos x is given as minus 1 by 2. So therefore you are having a sine square x is equal to, or plus 1 by 4 is equal to 1, which implies that sine square x is equal to 1 minus 1 by 4. So which implies that sine square x is equal to 3 by 4, which implies that sine x is equal to root of 3 by 2, taking square root on both sides. So you are getting sine x is equal to plus or minus, actually it is plus or minus, but here because cos x is lying in the third quadrant, you know that in the third quadrant means it's given in the problem that it lies in the quadrant. So this is q1, q2, q3, q4. So in all these you are having all silver tea cups, means in the third quadrant we have tan as positive. So we are, since sin x is equal to plus or minus root 3 by 2 means here you are having, since it lies in the third quadrant, it is equal to minus, only tan and cot can be positive over there. So therefore this is equal to, the sin x is equal to minus root 3 by 2. Now we know that, we also know that sin x can be written as 1 by cosecant x. It's the inverse of cosecant x, so which is equal to, so here, which implies that cosecant x is equal to 1 by sin x, so which is equal to 1 by minus root 3 by 2, which is equal to minus 2 by root 3. So since here you are having in the third quadrant, this is also negative, so you have tried this as negative. So we got here cos is negative, secant is negative, sine is negative, cosecant is negative we got. Now in the third quadrant we know that all silver teacups means tan and cot are only positive. So here with whatever values we get for tan and cot, we have tried that as positive, because in that third quadrant they are positive. So now here you having tan x is equal to, what can tan x be written as? Sin x by cos x, which implies that what is sin x? Sin x you got it as, you know that it is equal to minus root 3 by 2. And what is cos x? It's given to us as 1 by 2, minus 1 by 2. So 2 will get cancelled, this minus minus will get cancelled. So root 3 is the answer for tan x, and cot x is equal to 1 by tan x, which is equal to 1 by root 3. So therefore the answers we got here are, first we have what is sin x. Sin x is equal to minus root 3 by 2. Then we have what is cos x is given to us, it is minus 1 by 2. Then we have what is tan x, it's equal to root 3 we got. Then we having what is cosecant x, which is equal to reverse of this, that is minus 2 by root 3. And then we have here secant x, which is equal to minus 2, and cot x is equal to 1 by root 3. Since it lies in the third quadrant, we can see that tan and cot are positive over here. So next, second problem. What is the second problem? So in the second problem, it is given that sin x is equal to 3 by 5. X lies in the second quadrant. So now in the solution part, what do we have? We have that given sin x is equal to 3 by 5. So we have to find out all the remaining, what are all the other trigonometric functions. So in order to find out that, we are given here in this case as sine. So we can obviously find out what is cosecant x. So here cosecant x is equal to, you having cosecant x is equal to 1 by sin x, which is equal to 1 by 3 by 5, which is equal to 5 by 3. So now we also know that, we know from the identity that, we know that sin square x plus cos square x is equal to 1. So therefore here you are having it as sin square is nothing but 3 by 5, or we can write down here cos square x is equal to, or 3 by 5 whole square plus cos square x is equal to 1, which implies that from this you can take it as, here you can write this as 9 by 25 plus cos square x is equal to 1, or cos square x is equal to 1 minus 9 by 25, which is equal to 25 minus 9 divided by 25, which is equal to 16 by 25. So therefore cos x is equal to plus or minus root of 16 by 25, which is equal to plus or minus 4 by 5. So now here x lies in the second quadrant, you know that it's given to us. So this is quarter 1, quarter 2, quarter 3, quarter 4. So therefore you are having all silver, tea, cups. Now here, since this lies in the second quadrant, in the second quadrant we have sine and cosecant as positive, the remaining all will be negative. So therefore cos x is equal to plus or minus 4 by 5, means here you are having cos x is equal to minus 4 by 5. Next, from this you can write secant x is equal to 1 by cos x, which is equal to 1 by minus 4 by 5, which is equal to minus 5 by 4. So therefore we got here secant x also. Now we'll write down what is tan x. Tan x can be written as equal to sin x by cos x, which implies that sin x is given to us as what? It's given to us as 3 by 5. 3 by 5 by minus 4 by 5 is cos x. So therefore from this you can see this 5 will get cancelled. So it is minus 3 by 4 is tan x. And now you have what is cot x is equal to 1 by tan x, which is equal to 1 by minus 3 by 4, which is equal to minus 4 by 3 is the answer. So we got all the trigonometric ratios, all the 6 trigonometric ratios. We are having sin x is equal to, it's given to us as 3 by 5. So we are having here cosecant x is equal to 5 by 3. Next we are given that cos x is equal to minus 4 by 5. and here secant x is equal to minus 5 by 4. Then we are having what is tan x. Tan x is equal to minus 3 by 4. Therefore cot x is equal to minus 4 by 3. So therefore we got all the trigonometric ratios for this. Next we'll go into what is the, so now for us what is the third one is given to us. Here in the third one we can see that because from 1 to 5 problems we have to do it in this way. We have to find out all the trigonometric ratios. So here cot x is equal to given. So in this it is given that cot x is equal to 3 by 4 and it also lies in the third quadrant. Now all silver teacups, when we are taking third quadrant, cot is there. So therefore tan and cot will be positive over here. So you are having cot x is equal to 3 by 4. So from this we can write down what is tan x is equal to 1 by cot x, which is equal to 1 by 3 by 4, which is equal to 4 by 3. Next, we also have 1 plus tan square x is equal to secant square x. So 1 plus 4 by 3 whole square is equal to secant square x, which implies that secant square x is equal to 1 plus 16 by 9, which is equal to 9 plus 16 by 9, which is 25 by 9, which is equal to secant x is equal to plus or minus root of 25 by 9. Since it lies in the third quadrant, we are having only tan and cot as positive, secant will be negative, so it will be minus 5 by 3 is the answer for secant x. Now next, since it lies in the third quadrant, since you can see from this, all silver tea cups, so this is Q1, Q2, Q3 and Q4. In Q3 you have tan and cot as positive, so that only we have written. So since it lies in third quadrant, secant x is negative. So therefore now you have what is cos x, you can find out from this. It's equal to 1 by secant x, which is equal to 1 by minus 5 by 3, which is equal to minus 3 by 5. So this is what we are getting, minus 3 by 5. Next, what is tan x, we'll see over here. Tan x is equal to, tan x can be written as sin x by cos x, which is equal to, we got here what is sin x, we did not get what is sin x here, isn't we having only tan and cos. So we'll first write down those two. So from this you can write down that. So now going into the fourth one. In the fourth one we have secant x is equal to 13 by 5. X lies in the fourth quadrant. So solution for this is, you are having here secant x is equal to 13 by 5 and here x lies in the fourth quadrant. In the fourth quadrant, what we have, all silver teacups, isn't it? So we are having secant and cot, cos as positive. So you can see that here, if it is having this is quadrant 1, quadrant 2, quadrant 3, quadrant 4. So here you are having this as all silver tea cups. So in quadrant 4 we have cos and secant as positive, the remaining all will be negative. So here you are getting now what is cos theta equal, cos x equal to, cos x is equal to 1 by secant x, which is equal to 1 by 13 by 5, which is equal to 5 by 13. So we got of secant x and cot x. Now we can use the one more identity. What is that identity which we can use here? We can also write here sin square x by cos square x is equal to 1. So sin square x plus cos square x is equal to 1. So we can write this as sin square x plus 5 by 13 whole square is equal to 1, or you can write this as sin square x is equal to 1 minus 5 by 13 whole square, which is equal to 169 minus of 25 divided by 169, which is equal to 144 by 169. So therefore you are having here sine square x is equal to 12 by 13 whole square. So which implies that sin x is equal to plus or minus 12 by 13. Since x lies in the fourth quadrant, we are having cos and secant as positive and the remaining all are negative. Therefore here sin x is equal to minus of 12 by 13. Now since we got sin x, we know how to write down what is cosecant x, which is 1 by sin x, which is equal to 1 by minus 12 by 13, which is equal to minus 13 by 12. So this we got for cosecant. Next we can write for tan. Now tan is nothing but it is equal to sin x by cos x. So here we are having in this problem what is sin x. From here you can see it is 12 by 13, and here we also have what is cos x, it's equal to 5 by 13. So it's 5 by 13, 13 will cancel, so we are getting 12 by 5 as, and since this is in the fourth quadrant, it is equal to negative because you are having for sin as negative. It is minus 12 by 13. Then we are having what is cot x is equal to 1 by tan x, which is equal to 1 by minus 12 by 5, which is equal to minus 5 by 12. So this is the answer for fourth one. That means you know from here what is sin x, cos x, all those values you can write down here. Sin x is equal to how much? Then you are having cosecant x is equal to how much? Then what is cos x? Cos x is equal to how much? Then you are having cosecant x, secant x. Secant x is equal to how much? So secant x is equal to how much? We'll just write down. Then tan x and cot x. So over here we are having these two, minus 12 by 5 and this is minus 5 by 12. Cosecant and secant means you are having a sine, cos and sine. Cos is, secant is 13 by 5. Secant is 13 by 5. So cosecant is, cos x is 5 by 13, reverse of secant. So the cos x is equal to, these two are only positive, the remaining all are negative. So then we are having what is sin x equal to? Sin x is equal to minus 12 by 13. Minus 12 by 13, and the reverse of sin x, that is cosecant x, is equal to 13 by 12. This is minus sin. Problem, we have tan x is equal to minus 5 by 12. X lies in the second quadrant. So in the solution part, what do we, since tan x lies in this, x lies in the second quadrant, in the second quadrant we have sine and cosecant as positive. So therefore here this is the first quadrant, second quadrant, third quadrant and fourth quadrant, all silver tea cups. So in the second quadrant we have sine and cosecant as positive. So therefore here tan x will be negative. So tan x is equal to minus 5 by 12. So given this, we can find out what is cot x. Cot x is equal to 1 by tan x, which is equal to 1 by minus 5 by 12, which is equal to minus 12 by 5. Next, we can write what is 1 plus tan square x is equal to secant square x, which implies we get here 1 plus of minus 5 by 12 whole square is equal to secant square x, which implies that this is 1 plus 25 by 144 is equal to secant square x, which implies that 144 plus 25 divided by 144 is equal to secant square x, which implies that secant square x is equal to 169 by 144. So here in this secant x is equal to root of plus or minus root of 169 by 144, which is equal to plus or minus 13 by 12. So now since it is lying in the second quadrant, secant x will be negative, because we have in second quadrant sine and cosecant will be positive. So therefore, since x lies in the second quadrant, secant x will be negative. So therefore secant x is equal to minus 13 by 12. So from this we can find out what is cos x. Cos x is equal to 1 by secant x, which is equal to 1 by minus 13 by 12, which is equal to minus 12 by 13. This is cos x. Next we have to find out what is sine. So in order to find out sine, you know that tan x is equal to sin x by cos x. So we have what is tan x given as. Tan x is given as minus 5 by 12. So minus 5 by 12 is equal to sin x by cos x is minus 12 by 13. So which is implies that sin x is equal to, you take the denominator across, multiply it the other side. So minus 5 by 12 into, here you are getting it as again minus 12 by 13. So 12 will get cancelled, minus minus will become positive. So therefore the answer is 5 by 13. So you are getting, this is sin x 5 by 13. Now what is cosecant x? Cosecant x is equal to 1 by sin x, which is equal to 1 by 5 by 13, which is equal to 13 by 5. So now what are all the values? We'll write down here. What is sin x is equal to, just now got it as 5 by 13. Cosecant x is equal to 13 by 5. Then we know that what is cos x equal to, cos x is equal to minus 12 by 13. Secant x is equal to minus 13 by 12. Then we have what is tan x. Tan x is given to us, so we are having it as minus 5 by 12, and cot of x is equal to minus 12 by 5. So we are having tan x as equal to 4 by 3. 4 by 3 is equal to sin x by minus 3 by 5. So now if you take to the other side, it becomes, here this becomes 4 by 3 into 5 by 3 with a minus sign, which is equal to sin x. And so right in the next is 4 by 3 into minus 3 by 5 is equal to sin x. So 3 will get cancelled. So sin x is equal to minus 4 by 5 is the answer. So therefore what are all the values? We'll write down. Sin x is equal to minus 4 by 5. From this we can write down, we are having what is cosecant. So from this cosecant will be equal to nothing but cosecant x is equal to 1 by sin x, which is equal to minus 5 by 4. So here cosecant x is equal to minus 5 by 4. Then we will have what is cos x. Cos x, here from here you can see it is minus 3 by 5. Minus 3 by 5. Secant x is equal to minus 5 by 3. And here you are having what is cot x. I'm sorry, tan and cot. Tan x is equal to you are given that it is 4 by 3 and cot x is equal to 3 by 4. This is the answer for this. In the sixth problem, from 6 to 10 we have to find out the values of the trigonometric functions. So in this we can see what is sine 765 we have to find out. What is the solution for this we'll see. 2 pi sin x repeats after an interval of 2 pi. So we are 360 degrees. So here you have in this that if this is x-axis, x dash y dash, we know that this is 0 degrees, this is 90 degrees, this is 180 degrees, and this is 360 degrees. I'm sorry, this is 270. We have this as 270 degrees, and this is again 360. So after every 2 pi interval, sin x repeats itself after every 2 pi degrees or 360 degrees. So here you can see that we know that the values of sin x repeat after an interval of 2 pi or 360 degrees. So we have that sin 65 can be written as sin 765 can be written as equal to sine of 720 plus 45, isn't it? So which is equal to sine of 2 into 360 plus 45. So therefore here you have this is equal to sine of 45 degrees. So you have sine of 360 plus 45 is nothing but sine 45, because for sine of 180 plus or minus theta, for sine of 360 degrees plus or minus theta, you know that the trigonometric functions won't change. So here you will be getting it as sine 180 plus or minus theta will be equal to sine theta, and sine 360 plus or minus theta will be equal to sine theta itself. But it remains here, you have to see where you are getting plus or minus. So here you are having sine 45, it lies in the first quadrant, therefore this will be always positive. All the values, all the trigonometric functions are positive, therefore this is equal to 1 by root 2, where sine 45 degrees is equal to 1 by root 2. So now the seventh one is cosecant of minus 1410. So here again we have in the solution that after an interval of 2 pi, cosecant x again repeats itself. So we know that values of cosecant x repeat after an interval of 2 pi or 360 degrees. So we get here cosecant of minus 1410 degrees is equal to cosecant of, you can write this as minus 1410 degrees plus 4 into 360 degrees. So this is equal to cosecant of minus 1410 degrees plus 1440. So this is equal to nothing but it is equal to cosecant of 30. Since it is lying between 0 and 90 degrees, this cosecant theta, so therefore here you get it as a positive value, therefore cosecant 30 is nothing but equal to 2 degrees. Next, going into here, it's given as tan of 19 pi by 3. So here again we know that tan x also repeats itself after an interval of pi or 180 degrees. So therefore we know that values of tan x repeat after an interval of pi or 180 degrees. So therefore we get tan 19 pi by 3 is equal to, if you are dividing, you get it as 6 1 by 3 pi. So this can be written as equal to tan of 6 pi plus pi by 3, which is equal to 6 pi is nothing but 6 into 180. So it repeats itself after pi degrees or 180 degrees. So which is equal to tan of pi by 3. So here this is, which is equal to tan of 180 by 3, which is equal to tan of 60. Since it lies between 0 and 90, therefore it's positive, therefore you're getting this as equal to root 3. So going into the ninth problem, here you're having ninth one, sine of minus 11 pi by 3. So this here again you can see that sin x repeat after every 2 pi, after an interval of 2 pi or 360 degrees. So therefore here you get the values of sin x repeat after an interval of 2 pi or 360 degrees. So therefore we have sine of minus 11 pi by 3 is equal to sine of minus 11x by 3 plus 2 into 2 pi. So here you can see this is equal to 4 3s are 12, 12 minus 11x. So this is equal to, you're going to get it as equal to sine of pi by 3. So which is equal to root 3 by 2. So which is equal to, the answer is root 3 by 2. Since pi by 3 is nothing but sine 60, it's equal to root 3 by 2. So we are writing it as a product of 360. So whenever it is a product of 360, 360 into whatever is the value plus theta will give you that theta value. So when you are adding over here, you are getting it as pi by 3. So minus 11 by x by 3 plus 4 pi will give you pi by 3. That's why you are getting the value as sine 60, which is equal to root 3 by, given as cot of minus 15 pi by 4. So here again we know that it repeats after every an interval of pi degrees or 180 degrees. So we can write this as, we know that values of tan x repeat after an interval of pi or 180 degrees. So therefore you get that cot of minus 15 pi by 4 can be written as cot of minus 15 pi by 4 plus 4 pi, which is equal to, here you are getting cot of pi by 4, because this will be equal to cot of minus 15 pi plus 16 pi by 4. So which is equal to cot of pi by 4, which is equal to 1. That is 45. So therefore the answer over here is equal to 1.